The topic of this lecture is solution methods and controls. Since we are choosing the pressure based solver, which is the default condition in the fluent, as you can see here in the general tab, the type of solver is the pressure based and second solver is the density based. The density based solver is used when the flow is compressible and the pressure based solver is used when the flow is incompressible. And as we have already done this thing that the Mach number is around 0.1 and any Mach number which is less than 0.3, the flow is assumed to be the incompressible. When the flow is compressible, we take all the equations. All the equations means that the continuity equation, which is the conservation of mass, the conservation of momentum, are the Navier-Stokes equations, and the energy equation, they are solved together. The second method, which is pressure based solver, traditionally there was a single approach which was known as the segregated solver. It means that we solve all the equations like continuity, momentum and the energy if needed. They all will be solved in a serial fashion. It means that first we solve the continuity equation, then momentum, then again continuity and then momentum. When these two fields are satisfied, then we go to the energy and then turbulence and the species if the chemical type of solution is being solved. Now new approach which we are going to use is a coupled. In this approach, the continuity and momentum equation, they are solved together. It means that we modify the continuity equation for the pressure field and then assumed pressure field is from the momentum equation. We put the assumed pressure field and we get the velocities, and then we put the values in the continuity equation, then so on. So this is how the coupled solver works. The major advantage of coupled solver, you can search on the internet, that is that the coupled solver can work on the both sides of the equations, means that it can work for the compressible as well as for the incompressible. Secondly, it slightly uses more RAM as compared to segregated solver, but it gets results within a very few iterations. For example, if you use the simple method, which I'm not going to describe here, simple, simplex or piezo, if they require 10,000 iterations, you can get a solution within maybe 500 iterations in the coupled solver. And the RAM it uses is slightly greater as compared to the simplex, but it's very less as compared to the density based solver. So it has the advantage of that it can solve the flow slightly compressible. It can solve the flows which are coupled from the inner momentum and the continuity equation point of view. So it solves the major problems in the solution convergence. That's why most of the time when the flow is compressible, we will be using the coupled solver. And here we have the solution flow current number. This flow current number is different than the normally we see the current number in the CFD. This is the pseudo type of the time step. And the maximum value, I would suggest you can go up to the 2 million if solution is behaving properly, and the minimum value is 20. But any value less than 20, you should be solving the problem using the simple, simplex or the piezo. So there is no point to reduce the current number less than 20. We set this on the fluent. Okay, here in the methods, choose the scheme of the pressure velocity coupling to be the coupled and keep everything in the default form. And in the controls, change the flow current number to the 2000, or you can keep the default condition here as well. Okay, in the next lecture we will discuss about the report definitions, for example, to report the monitors and in the text form the value of the drag and the lift coefficient.